Good morning, everyone. Welcome to the Nomenclature family, a family that would take us on an interesting ride on the journey of nomenclature of organic molecules. Now, what exactly is nomenclature? It means simply to assign name to any substance. It can be of two types. It can be common or also known as trivial nomenclature, which varies from place to place and language to language. For example, must be having a different name at your home, whereas a different name at the school. The school name is the IUPAC name, which this family will be dealing with, and this depends upon the rules which are given by IUPAC. First, let me introduce to the characters of the family. He is Mr. Carbon Roy, aka the family root. She is her wife, Mrs. Diamond Roy, aka primary suffix. Then comes Mrs. and Mr. Graphite, aka secondary suffix. And lastly comes the little fullerenes, aka the prefixes. Hi everyone, I am Mr. Carbon Roy, the oldest member, and it is me who will take you to the nomenclature family. I'm the root of the family and represent the number of carbons in the chain. For example, if the number of carbons in chain are 1, then my root becomes myth. It is 2, my name becomes it. For 3, it becomes prop, and so on. The chain length goes on and on. Now meet my wife who completes me. How? Well, she is here and would tell you more about this. Hello everyone. Exactly. I complete him by acting as his primary suffix. I am Mrs. Diamond Roy and tell whether the chain is saturated or unsaturated. That is, whether the compound is having a single bond and alkane or whether having a double or a triple bond, alkene and alkyne respectively, depending upon whether the chain contains a single bond. My name can vary from "ane" to double bond becomes "ene", and for triple bonds it becomes "ine". Now meet the youngest members of the nomenclature family, who we keep on top of our eyes. Hello everyone, we are the little fullerenes and are so loved by everyone that we are always first in making every wish, and that is why we are the prefixes and represent the substituents present in the chain. For example, if the substituent present is CH3, our name becomes methyl. For OCH3, our name becomes methoxy. And for Cl, it becomes chloro. For Br, it becomes bromo. And this is a list of the commonly used substituents that represent our names. You would be getting bored without any examples. We will move to that in a while. Firstly, let's see the order in which we are placed. So firstly comes the prefixes, our little ones representing the substituents, then comes me, who represents the number of carbons, and lastly comes my better half, who represents the primary suffix in, and "ine". We three can help you with the nomenclature of alkanes, alkenes, and alkynes. Let's have a look at few examples and their related rules. Firstly, let's see at the alkanes, the saturated compounds. The first rule comes the selection of the parent chain. That chain is selected, which is the continuous longest chain containing the maximum number of carbon atoms. For example, in the given example, if you see the straight chain, you would be wondering that only 5 carbons are present. But in actual, the continuous longest chain is the one which I enclosed in the square brackets, which is containing 7 carbons. And corresponding to 7, my word root becomes hept. But before we write the name, let's see at the another rule, the lowest locant rule. It says that the substituent should get the lowest number. However, if you see this compound, whether you do the numbering from the lower right hand corner or the upper right hand corner, the two substituents, which are the methyl groups, which are not the part of the chain, would come at the similar positions at the third and the fifth position. Therefore, in this given example, we can number it from either way. Now, on the third and fifth position, we have methyl groups, so it becomes 3, 5 dimethyl. It is a 7 carbon chain, so word root becomes hept, and since it is an alkane, so my primary suffix, that is my wife's names, would be in. Let's see. So firstly, we'll mention the position number of substituent, followed by name of the substituent, then comes the word root and the primary suffix. Here at the third and fifth position, we have dimethyl, so 3, 5 dimethyl hept A, that would be the name of the given compound. Let's also see an example where lowest locant rule would be applicable. Now, in the given example, if you start numbering from the right-hand side, chlorine from the would be on third position, whereas bromine would be on fourth position, which I don't think would be right as per the lowest locant rule. Because if you number it from the left-hand side, bromine will come on the second position and chlorine will come on the third position. And then we will write them in alphabetical order. So the name becomes 2-bromo, 3-chloro, for 5 carbon, it is my word root becomes pent and A since it is an alkane. So the name would be 2-bromo, 3-chloro, pentane. Now let's go through an example of unsaturated compound. Here also, rules would be almost similar with a few changes. Let's see. Now, in case of unsaturated compounds, the parent chain becomes the main chain, which has the maximum number of multiple bonds. And the numbering should be done in such a way such that multiple bonds get the lowest numbering. Let's have a look at an example. In the given example, if you just go through it, you would find that the longest chain contains 7 carbons, but it violates the first rule, where we say that the chain having maximum multiple bonds becomes the parent chain. And that is why the highlighted chain would become the parent chain, which is having 2 double bonds. And then we would follow the second rule. We would start numbering from the lower right hand corner in order so that the multiple bond, the double bond gets the lowest numbering. So this would be numbered in such a way. Now we are having double bond at the first and the third position, whereas on the second position, we are having a propyl group. So the name becomes 2-propyl. It is 5 carbon chain, so pent. At first and third position, we have double bond, so 1, 3 diene, and we attach an A after pent because my primary suffix is not ending in a vowel. So the name becomes 2-propyl penta 1, 3 diene. Now let's meet the final and the most awaited members of the family, my son and his wife, who are truly responsible for extending the nomenclature family. Let's see how. Hello everyone, we are their successors, the secondary suffixes. We are Mrs. and Mr. Graphite and tell what kind of functional group is present in our family chain. For example, if the functional group is alcohol, which is represented by OH, so our names become OL. For CHO, which is an aldehyde group, our name becomes AL. For COH, which is a carboxylic acid, our name becomes oic acid. And this table represents some of our commonly used names for commonly used functional groups. Well, they are placed at the end of the chain and completes the nomenclature. This is how our nomenclature family looks like with their inclusion. Firstly comes our little ones, the prefixes representing the substituents. Then comes me with the word root followed by my wife representing whether it is the chain contains double, triple, single bond. And lastly comes my son and his wife representing the functional group. Both of them gets the top priority in selection of parent chain and also while considering the lowest locant rule. Let's see how the order changes with their inclusion. In selection of the parent chain, the functional group gets the top priority, followed by multiple bond and then the carbon atoms. Similar order would be followed while we are following the lowest locant rule, that the lowest number should go to the functional group, then to the multiple bond, and the lowest one goes to the one with the substituents. Let's have a look at the final example. In the given example, we are having alcohol functional group, which is present on the rightmost carbon. So that is why we would give it the top priority and we would give it the lowest numbering. And hence, our numbering starts from the right hand side. On the second position, we have a chlorine. On the third position, we have a methyl group. So that is why our odd name becomes 2-chloro, 3-methyl. It is a 4-carbon chain. So buta, on the first and the third position, we have double bond. So buta 1,3-diene, and on the first position, we have alcohol 1-ol. So the name becomes 2-chloro, 3-methyl buta 1,3-diene 1-ol. I hope you all had a wonderful time with our nomenclature family. Thank you, Adios.